Okay, so now that we've gone over kind of what a regression is, both linear and logistic, let's run some examples of this in Stats IQ so you can learn how to do it. We're going to first start with a linear regression. And so if we go back to the little table I created, the overview table, we can see that we're doing a linear regression if our input and our output are both numbers. And what we're going to be looking at is p-value, of course, but we're also going to be interpreting the results with a beta as our metric. So for this data set, we're going to be using the nom data set that we've been using the past few weeks. This first example, I'm going to look at purchase account. Okay, I want to know what can predict purchase account. This is a number. Again, this has the little bar graph here that tells me that it's a number. If it has these bullet points, it's a category. And if it has these numbers with this little line, this little icon here, then it's also a number. Okay, so I'm going to select purchase count as a number, as my output. And let's say I'm going to, let's say trust, how much they trust the influencer, all right? Now remember, when I first set this up, the default for Stats IQ is that this key icon here is for your output variable, all right? So since purchase count in this case is my output, say I want to say, does the trust that a customer has toward an influencer, does it predict the number of purchases they have toward our company when that influencer recommends it, right? So I got that, and I'm going to click relate. And right here, what's nice is, as we talked about in the last video, here's our slope, all right? So you could tell just from this that it's positively sloped, right? But you'd also want to take into account a p-value, of course. So this is sloping upward, but is it significant? Is it something that you can rely on, or is it something that's highly due to chance? But we know already that it's going to be a significant p-value because of this sentence. Purchase count is positively correlated with Q9, the trust the influencer has. So we know we're going to have a significant p-value. We know that the relationship is positive, but we do want to see what that p-value is, and we want to see what the beta is. So I'm going to click here to show statistical test. Here I have my p-value, like the other analyses that we had before. So there's 1.3% likelihood that this relationship here is due to chance. That's great. That's significant. Now the beta, I do wish Stats IQ would come out and show the beta like more prominently, but it doesn't. The beta is right here, this 0.608. That's my beta. It's putting it here in this equation. We're not actually going to run the equation in class, but what this equation would say is that as trust in influencer goes up by 1 point, it's going to multiply that by 0.608. So we'd expect that purchase count would go up by 0.608, all right? As our input goes up by 1 point, we'd expect our output to increase, since this is a positive beta, by 0.608. Okay, so that's pretty straightforward. Let's do another example just for kicks. Let's try Rage Typer. I'm going to have Rage Typer as my input, then I'm going to click relate. Okay, so we have our sentences as a strong negative correlation. I'll click here. Okay, p-value is very, very low. This is very significant. There's a very, very low likelihood this is due to chance, right? And then right here is our beta. It's a negative beta this time. So in this case, we'd say that the amount of rage typing that they do is, as that goes up by 1 point, we'd expect that the purchase count would go down by 0.994. And let's just do one more for good measure. I'm going to try nose trends, and let's say engagements. How many engagements they have with our social media posts. I'm going to make sure the key is on here. I want this to be my output in this case, and I'm going to click relate. And here I'm also getting a negative correlation here. So here's our p-value. That's significant, definitely below 0.05. And then and my beta is right here. It's a negative 24.3. So in this case, I'd say like the more that they know the trends is that goes up by 1 point, we'd expect that the number of engagements that they have with our brand would go down by 24.3 points. So I hope that's helpful. This is very straightforward. Most of you shouldn't have a problem with this, but be sure to let me know if you are still struggling with linear regression. Now let's go with logistic regression now, okay? Logistic regression typically is a bit more complicated, but as I talked about in the last video, this is Stats IQ is going to display a logistic regression the same way it would display a t-test or an ANOVA. And so the logistic regression is going to look a little different depending on how many categories our output has, similar with t-test and ANOVA, right? If our output has 2 categories, it's going to be very straightforward. If there's more than 2 categories, we got to do a little bit more investigation to see what's going on. So let's start out with something simple, something with just 2 categories. So I'm going to say, let's see if the number of engagements that a customer has with social media, if that can predict the type of influencer that they're interacting with. Let's say that it's a macro or a micro influencer, okay? Macros are like big time influencers. Micros are less big time influencers, but they're more like specialized. Okay, so I'm going to have influencer type as my outcome. There's only 2 categories, macro and micro, and then engagements as my input. So output and input, and then I'm going to click relate. And right here, I see. So it's going to tell me that micro tends to have higher values for engagement than macro. All right, and this is going to look very much like a t-test. Let me scroll out here a little bit so we can see everything there. Let's pop over here to see the statistical test. Here's my p-value, and then here are my averages. So you can see that micro is higher on engagements than macro, all right? Now, since this is a regression and engagements is my input, this is the way I want to look at this. I want to say, okay, as engagements gets higher, are they more likely to be macro or micro influencers? And because micro is higher here on average than macro, then I'd say, okay, they're more likely to be micro. The more engagements we get, the more likely it is to be a micro influencer. And you could say that the opposite too. It's the more engagements that you get, the less likely they are to be a macro influencer. All right. Let's try this again with video quality. So this has 2 categories as well. Let's see what this looks like. Okay, this is saying there's no statistically significant relationship between engagements and video quality. If I click here, yeah, that p-value is not significant. We're not really finding anything at all, right? There's a 43.5% likelihood that this relationship is due to chance. We're going to throw it away, all right? But let's say that that it is significant, just for kicks. If this was significant, then we're going to look here at the averages. We see casual vlog is higher than high production. So what we would say is, as engagements gets higher, it's more likely that the video was a casual vlog style video than a high production video. Okay, so we're going to try another one just for kicks to really hone this in. We're going to try the degree that they buy influencer products as our input and video quality as our output. Let's run this. Okay, so we see that there is a significant relationship. Here's our p-value. And right here we see that casual vlog style is higher than high production. So what we'd say is, as the degree that they buy influencer products, as that increases by 1, it's more likely that the video was a casual vlog style video than a high production video. Okay, so now that we've gone over a couple of those where our output just has 2 categories, which is technically it's a binomial logistic regression. Let's look at a multinomial logistic regression. All right, so this is what happens if your input is still a number, but your output is categorical and has more than 2 categories. So for this example, let's see if we could use Q3 as our input, which is the number of personal comments they leave on social media posts. And let's see if we could use that to predict what type of influencer they're interacting with. So if we do this and click relate, we see there is a significant relationship. And this is going to look very much like ANOVA that we did last week. I click here, here's our p-value. So yeah, definitely significant. And here are the averages. All right, so we could kind of see, we don't quite know yet if these are significant differences, just like the ANOVA last week. Just because this is significant, it doesn't mean that personal comment predicts the differences between all of these. I mean, look, for instance, we have lifestyle creator and beauty influencer. Those are exactly tied. So obviously, personal comment isn't going to predict the difference between those two because it's exactly tied. So we need to check which of these personal comment does significantly predict like differences between. So to do that, we're going to click here on show pairwise comparison, and we're going to look at the p-values. And what I see here is only one significant p-value right here, and that's between fitness influencer and gamer. So we look here, we have fitness influencer has a 2.67 and gamer has a 4.11. All right, so we're going to look at this the same type of way that we just looked at the last one with 2 categories, but only for these significant differences. So we'd say that as Q3, as personal comments gets higher by 1 point, it's more likely that the influencer is a gamer influencer than a fitness influencer, right? Because gamer has a higher average. Let's say here that this p-value between fitness and food blogger was also significant. It's not, it's getting there, it's not marginal or anything like that. It's a 0.167. But let's say that it was significant, just for the sake of another example. So then we'd look here at fitness influencer. We already saw that, 2.67. And then food blogger is right here, 3.57. So what we'd say is, as personal comments go up by 1 point, it's more likely that the influencer was a food blogger than a fitness influencer. Again, if that p-value here was significant. Okay, so let's do one more. Let's look at competitor preference, whether they prefer brand A, B, C, or nom-nom. And then and let's use our input. Let's have that be buys influencer products. So the how frequently they buy influencer products. Then I'll click relate. And it's saying there's no statistically significant relationship between these two. Let's take a look at the p-value. Hey, look, I'm getting a marginally significant p-value, 0.0752, right? So there's a 7.52% likelihood that this relationship is due to chance. That's low. I'm gonna take it. It's not quite statistically significant, but marginally so. Let's look at this pairwise comparison table. And looks like there's no difference. Oh, there's a marginally significant difference right here between nom-nom and brand A. All right. So what I look up here and I see nom-nom is 4.33 and brand A is 2.8. So it's higher in nom-nom. So as the buys influencer products, as that goes up by 1 point, I'd expect that that they're more likely to prefer nom-nom than brand A. All right. Now let's say that this right here was also significant. It's not getting there. It's a 0.147, so it's not even marginal, but let's just say for kicks that it was. That'd be between brand C and nom nom. Brand C, you can see here, is lower than nom nom, so you'd say, okay, as it buys influencer products, as that goes up by 1 point, it's more likely that they prefer nom nom than brand C. Okay, I hope that that helps. You can't really, when you have multiple categories for your output, you have to kind of, and you're doing a regression, you have to kind of look at them one category at a time and see, okay, does this input, does it predict the difference between these two categories? How about these two and these two? And you have to kind of look at all combinations. But it can be really helpful. You could see you'll have cases where say nom nom, this one was significantly higher than all the other categories, and so you'd see, oh yeah, buys influencer products, predicts the difference between nom nom and all these other ones, and the higher buys influencer products gets, the more likely it is that they prefer nom nom over these other competitor companies. So I hope that that's clear and that helps you out. Be sure to reach out if you have any questions as you do the assignment. And I wish you the best of luck.